Today my presentation regarding thermodynamics paper is Rankine cycle. So in Rankine cycle, it's a steam power plant cycle. So steam power plant cycle, the following steps to be discussed today. The first step is definition. What is define how to define this Rankine cycle? What are the principles of Rankine cycle? Then constructions, working, what is the energy analysis in Rankine cycle? How can we find out the efficiency of a Rankine cycle? Then we have to discuss more about the complicated and combined cycle. So this particular Rankine cycle, it's a modification of Carnot cycle. So when the Carnot cycle had been issued, it had some mistakes. So Dr. Rankine get the solution for updating the Carnot cycle. So this cycle is called as Rankine cycle. On behalf of his name, it is Rankine cycle. That is, the inventor name is Dr. Rankine cycle. Then the principles. The principles of Rankine cycle, it works on the heat engines. So heat engines, we know it converts chemical energy into the thermal energy. So chemical energy means the fuel and other things, it is converted into thermal energy. So we can use this thermal energy for power plant system. So next one is a construction of Rankine cycle. So regarding this construction of Rankine cycle, we have a different components in this cycle, but the main component we are going to consider is the steam boiler, steam turbine, steam condenser, and the other one is feed pump. Then we have a pressure. Then what are all the thermodynamic processes carried out in this cycle is isentropic system, constant pressure heat addition, isentropic expansion in the turbine, then constant pressure heat rejection. So these things will be explained using this particular diagram. So first one, we have a 1 and 2 is a feed pump, 2 and 3 indicates the boiler, 3 and 4 is a turbine, 4 and 1 is the condenser. So we can explain this particular diagram. Yes. Then the working process. Then the working process, we can start from the boiler. So in boiler, what happens exactly in boiler is heat supply. So heat supplied by the boiler. So what we have do is the addition of heat. Heat is added in this particular steam, particular processes, particular item, particular system. So in this system, heat supplied by the boiler. So the heat supplied is sent to the turbine. Then heat is not sent to the turbine. The heat supplied from the boiler, it is converted into, that is, the water is converted into steam. So this particular steam, it may be wet or dry or superheated steam. So if it is a dry steam, means it is totally saturated steam. So this particular steam is entered into the turbine. So what exactly happened in the turbine is the isentropic expansion happened in this turbine. So in the turbine, expansion takes place. So it is coupled to that shaft. So what happens here? The electrical, we have a electrical energy. That is, the mechanical energy is converted into electrical energy. So we can get the electrical energy from this turbine. So we can use this particular boiler and turbine for this Rankine cycle. Then the remaining things we can't use as it is. But as a mechanical engineer, we have to use the reheat, use the waste. So the waste means low heat, that is low pressure, low temperature heat comes out from the turbine. It is entered into the condenser. So what is condenser? Condenser is a device to condense the particular steam. So here the low pressure, low temperature steam is converted into water. So what is the output of the condenser here is only water. So this water is again pumped by the pump and it is fed into the boiler. So this is it's a cycle. It's a cycle. This particular cycle is invented by Mr. Rankine, so that it is called as Rankine cycle. So here I will again explain. Then 2-3 is the steam addition heat supplied. So at 3, steam is coming out. Then and it is entered into the turbine. It is entered into the turbine. So we have a 3 and 4 is the isentropic expansion, which is done in a turbine. Then 3, 4 and 1 is a condenser process where low pressure, low temperature steam is converted into water. Then 1, 2 is a feed pump. It is a isentropic compression. So pump is a device to just increase the pressure and it is entered into the boiler. So if you come to the right side of this slide, we have a TS diagram of a particular Rankine cycle. So the same TF cycle, we have a 2-3 process. 2-3 process is a isentropic 2-3 process a heat supply process. So what happens here? The heat is the water is slowly increased and it is entering wet steam, then dry steam, it may be become superheated steam. So 2-3 is a heat supplying process. Then if you come to the 3-4 process, it is a expansion process. Expansion process, what happens here is entropy remains constant. So we are getting a turbine output here. Then 4-1 is the condensation. Condensation, the steam is converted into what happens here? Water. Then 1-2 is the process in TS diagram, just increasing the pressure, just a small amount of temperature is also increased in the pump. Then, so this is a working process. I explained to you with the help of the diagram. Then energy analysis, how the energy analysis happens. So we have a analysis happened in terms of enthalpy. So what happens here is H1 minus H1. So what happens in the H1 is it is a saturated liquid with the low pressure. Then if you go to the pump work, that is pump work H2 minus H1. Then what is the heat supply process? So heat supply or heat addition is H3 minus H2. So small amount of mass flow rate takes place here. Then if you come again the same analysis, Q output. So output is heat removal. Output is heat removal H4 minus H1. So then what is the turbine work? The turbine work is H3 minus H4. So this is the analysis happen here. So in or whatever it may be the process, we are in a position to find out the efficiency of a cycle. So what is the efficiency? Efficiency means output divided by input. So in this particular Rankine cycle, what is a net output? That is work output. Work output means we can get the work from only from turbine. So some amount of energy is used for running a pump, running the pump. So the net output is turbine work minus pump work. Most of the cases, the pump work may be neglected. Very few amount of energy is used for running the pump work. So most of the cases the pump work may be neglected. So net work is equal to turbine work. So the thermal efficiency, you know, the net work done divided by heat supplied. Then ideal Rankine cycle. So the ideal Rankine cycle, you know, the process 1-2 is isentropic pump, 2-3 is the constant pressure heat supply, then 3-4 is the isentropic turbine and work done. So that's all about Rankine cycle. So from this Rankine cycle, we should know how the steam is generated in the boiler, then how the output of the steam is expanded in a turbine, then the output of the turbine is output of the boiler is expanded in a turbine. Then from the turbine we are having a low pressure, low temperature steam. It is fed into the condenser. Then it is again fed into the pump. So this is the cycle. This is invented by Rankine, so that it is called as Rankine cycle. So I think you are well familiar with this particular Rankine cycle. So this is also called as steam power cycle. Thank you very much.